New article. Let's get started. First of all, let me show you some vocabulary we're gonna need. So, this is Western Australia. I was pretty surprised to see the distance between Australia and Antarctica. It's a greater distance than I thought it would be. It's huge, incredible. There's no land. CETO, ancient Greek goddess or sea monster. Vast, huge or large. Adjective. Ripple. So ripple is like undulation, oscillation on the surface of a liquid. Roaring 40s. Roaring refers to the sound. The roaring 40s are an area of the earth between latitude 40 and 50 degrees south, and it is prone to the gale force westerly winds. Westerly winds refers to winds coming from the west. The winds blow. Take a look at the Spanish translation. The ocean swell. The way I like to explain this is the moon pulling on the gravity of the earth, thus creating a high tide or low tide. Perth. I actually found out that in Scottish it means forest, but there's a lot of towns in Scotland, New York, Australia. There's a town in New York called Perth. Greek, a person from Greece, or describing as an adjective something that is Greek. Greek goddess. Female deity. Okay, so let's get started with the article. It looks like an advertisement for Carnegie Energy. This is now a reality, so it's interesting nonetheless. The Economist, March 14th, 2015. Science and Technology. The ups and downs of modern sea power. Generating electricity from the ocean swell. Ocean swell causes buoys to rise and fall. There's a buoy, seabed pump, and the pump pressurizes the water. The high pressure water drives the turbines, and the low pressure water is returned to the ocean. Renewable energy from Carnegie Wave Energy looks well. We're just playing with words here. Looks well. Melbourne, a new project off the coast of Australia, may make wave power a reality. No land stands between Antarctica and Australia's west coast. Just a vast ocean, rippled and rocked by the roaring 40s. For centuries, these westerlies, which blow between latitudes 40 degrees south and 50 degrees south, powered ships sailing from Europe to Asia. These days, they were also creating waves in the world of renewable energy. At the end of February, a demonstration project designed to use the ocean swell they produced went live. As a result, Australia's largest naval base now gets part of both its electricity and its fresh water, courtesy of the 40s. Carnegie Wave Energy in Perth has been working since 1999 on what it calls CETO technology. And let's take a break here because I want to show you what these buoys or CETO technology looks like. Let's look for roaring 40s. So I just want to show you the ocean swell and the types of waves we get in these latitudes. So powerful. We're now using all that power to harness energy. Carnegie Wave Energy in Perth has been working since 1999 on what I call CETO technology. CETO was the ancient Greek goddess of sea monsters. And Carnegie's particular monsters are buoys that resemble giant macaroons. They float in a meter or two below the ocean surface, bobbing up and down in the swell and generating electricity as they do so. The current version, CETO 5, has a capacity of 240 kilowatt per buoy. 3 of the beasts are now tethered to the seabed 3 kilometers from HMAS Stirling on Garden Island. They also help to run a desalination plant on the base. For fresh water is a valuable commodity in Western Australia's arid climate. The buoys themselves are 11 meters across, made of steel and filled with a mixture of seawater and foam to give them a density slightly below that of water so that they float. Being submarine means that unlike previous attempts to extract power from waves, they are not subject to storms and the constant battering that life at the interface between sea and air brings. As Michael Ottaviano, Carnegie's boss, observes, savvy swimmers in Australia know to dive under, not through an approaching wave. To avoid getting smashed. The same applies to buoys. Let's take another break. There's another video I'd like to show you. Just a sec. Is about what they mention about savvy divers know to dive under the wave, an approaching wave. It's kind of like you're not going to fight force with force or fire with fire. There's got to be a smarter way, and that's diving under the wave, which is what the buoys are doing. They're on the surface, but they're not being hit by constant sun rays or wind or the battering that they would take at the surface. So they're right below the surface. So let's take a look at a diver here being savvy or smart. I love this graphic. It is so impressive. Look at the wind conditions. So that creates like a speedway through Australia. That was funny. That's the point. If you're savvy, if you're smart, you're gonna know you're gonna have to duck dive or dive under the wave. However, if you're not savvy, like one of those videos, you're gonna get smashed by a wave. The CETOs, or the sea monsters, buoys, are submerged. They're actually avoiding the power of the wind, wave, and sun. That's the point there. Mr. Ottaviano, Carnegie's boss, observes savvy swimmers in Australia, they know to dive under, not through an approaching wave, to avoid getting smashed. The same applies to buoys. Even below the surface, though, the swell is enough to generate power. Each buoy's rising and falling drives. As the diagram shows, a pump attached to the seabed at the bottom of that buoy's tether. This pump pushes water through a pipe to a power station on Garden Island. There, the water's pressure spins turbines that turn a generator. This arrangement produces about 5% of the base's electricity. The pressure can be put to a second use. Too, to run a process called reverse osmosis, which removes salt from water. Osmosis happens when a solution of salt and a body of pure water are kept apart by a membrane permeable to water molecules, but not to the ions of which salt is composed. The resulting osmotic pressure on the water propels it into the brine through the membrane. Apply sufficient physical pressure to the brine, though, to overcome the osmotic pressure, and H2O will go the other way, which is a neat trick if you want to desalinate seawater. Creating the necessary pressure requires a lot of energy. reverse osmosis desalination plants thus tend to guzzle diesel or electricity. But CETO 5 dispenses with all of that. It delivers water at a high enough pressure for reverse osmosis to happen automatically. As a result, about a third of Stirling's fresh water comes from desalination, driven by wave power. Carnegie aspires to bigger and better buoys. It hopes will generate a megawatt each when launched in 2017. These versions, CETO 6, will be 20 meters across and will produce electricity inside themselves instead of at an onshore power plant. That means no pipe is needed. Okay, so let's take a look at how this reverse osmosis system works with the brine, which is basically water mixed with salt water. That's brine.
The core technology used at the Adelaide desalination plant is called reverse osmosis. First, let's explain what osmosis is. Osmosis is a naturally occurring process in which a liquid, such as water, spontaneously passes through a membrane. The membrane or semi-permeable barrier allows some molecules, like water, through, but other molecules, like the majority of salts, are unable to easily pass through the membrane structure. The flow of liquid through such a membrane occurs naturally to try and even out the salt concentrations between the two solutions. That is, the liquid flows from the less concentrated solution, such as fresh water, to a more concentrated solution, such as seawater. When the direction of liquid flow is reversed, it's called reverse osmosis. By pressurizing the concentrated solution, in this case seawater, we are able to force water molecules in the reverse direction, from the salty seawater side through the membrane to the freshwater side.
Apply sufficient pressure through the brine, though, to overcome the osmotic pressure, and H2O will go the other way, which is a neat trick if you want to desalinate seawater. Creating the necessary pressure requires a lot of energy. Reverse osmosis desalination plants thus tend to guzzle diesel or electricity, but CETO 5 dispenses with all that. It delivers water at a high enough pressure for reverse osmosis to happen automatically. As a result, about a third of Stirling's fresh water comes from desalination driven by wave power. Carnegie aspires to bigger and better buoys. It hopes will generate a megawatt each when launched in 2017. These versions, CETO 6, will be 20 meters across and will produce electricity inside themselves instead of at an onshore power plant. That means no pipe is needed. A submarine power cable will do instead. This is just as well because the idea is to site CETO 6 further offshore, where the swell is greater but the difficulties of installing a pipe are too. Nor is there any need in the case of CETO 6 for machinery on the seabed to regulate the flow of water into the pipe. That reduces both capital and maintenance costs, and CETO 6 units are designed to be self-contained, so they can be towed back to land for upkeep. The lack of a water pipe means, of course, that CETO 6 will not be able to run a desalination plant directly. But in most of the world where rain is more plentiful than it is in Western Australia, reverse osmosis is a niche application. And if desalination really is desired, part of the electricity produced can be diverted to that use. The extra swell and lower running costs means that CETO 6 electricity will be cheaper than CETO 5's. Mr. Ottaviano reckons that if CETO 5s were deployed en masse in wave farms with a capacity of 25 megawatt, it could produce electricity at a cost of 30 or 40 US cents a kilowatt hour, which is competitive with diesel. At a similarly large scale, CETO 6 electricity would, Mr. Ottaviano says, cost about 20 cents a kilowatt hour. Ultimately, he thinks economies of scale could bring that down to 12 or 15 cents a kilowatt hour for a 100 megawatt wave farm. That is about the same as the cost of grid electricity in this part of Western Australia. allowing for the subsidy now given to renewable energy sources. Carnegie also has its sights on markets further afield. Military bases around the world need secure supplies of energy and water, and wave energy is attractive to island countries like the Maldives that must, at the moment, import fossil fuel at some expense. Whether submarine wave power of this sort will ever become truly mainstream is moot, but Carnegie is showing that in appropriate circumstances it could indeed have the wind behind it. Writing a monster. Thank you very much. Have a wonderful day. I hope you've enjoyed today's article.